I'm going to be grinding a couple of tools here in a minute. I'm going to grind a regular right-hand turning tool. Then we're going to cut some aluminum with it, and you're going to see the chip curls and the way that falls off. And then we're going to grind a chip breaker in it and see the difference that makes. And we're also going to do this little shear tool. Try that on a couple different materials and see how that goes. But before I do that, there were two cutting tools that I forgot to mention, and that's a part-off tool and threading tools. Now, I didn't make a mock-up or anything of these, so you have to bear with me with the small tools. Now, the cut-off blades that I use, there are two main types. There's a tapered blade type, which you can see the top is wider than the bottom here, so that's your clearance already built into it. And there's a T type, where it just has a T in a line, and the T is your cutting edge. Now, you grind the front here at the angle about 10-15 degrees, depending on the material there. But the biggest thing is, you notice on the top, you see this little line right here? It's kind of a ridge, and it's angled this way and this way off of that ridge. And that's kind of what grips your blade. There are cheaper versions of this. Let me see if I actually think I have a garbage one right here. Looks the same, pretty much, but if you look at the end, not a taper on the end. Also on the top, it's flat, and actually this is warped. But to grind it, all you want to do is grind and hone the angle. I see the burn marks in there. I did overheat this when I ground it the last time. That can weaken your blade. I haven't had a huge issue with it chipping or anything, but you want to make sure you keep it cool. That's a little too hot. But right at the tip here, you want a wheel radius dish on it. So all you would do is, this is your wheel. Take your tool and just hold it up against your wheel. The radius of your wheel will give you a little cupped grind on the top, and that'll let your chip come off and flow and curl around and break it. If you leave it, you have to get rid of that little parting line there, and you also want to give it a little clearance on the top so you present just that tip. And that's basically it with the part-off blades. Now, your grinding tools, these are two. I mean, you have multiple different kinds of threads, but for our case, most of it is going to either be a regular 60-degree thread or some sort of Acme thread. Acme threads are 29 degrees. Each comes with its own gauge. If you want to see a video of me actually grinding this tool here, which I use to do the compound screw, just follow this link right here. That entire video is just devoted to grinding that bit. Here's the gauge for that, and you can see these numbers here are actually the thread pitch. So this is 3 threads per inch, 6 threads per inch, 10 threads per inch, 1.5 threads per inch, and depending on what you have to fit that tip. I think we were 8 right into that notch, and you have to make sure it fits nice. An easy way to check that when you're checking is to get something white underneath there, and if you see white below that line, then you know you have to grind to fit. And then also, here's your 29-degree angle, and then that's to center yourself against the work. Now, same thing with your 60-degree threading tools here, just up against the wheel like this at about a 15-degree angle, and this at about a 15-degree angle. So that way there you get, you can see this right here, you get a clearance angle on everything on the side, so that this bottom edge here and this edge don't rub your thread as you're cutting. And then here's your gauges. Now, this is a craptastic gauge, and the actual ruler on it isn't even printed right. And there's nothing on the, well, maybe there is stuff on the other side. Oh, there's another ruler on the other side. It's cheap stamped metal, piece of garbage. It actually reminds me of those little keychain screwdrivers you get with your Craftsman sets. Much nicer one. You can see how much better this is compared to that other one, that other no-name one. This is Brown and Sharp. And then here's your 60-degree gauge here, and then here are your two parts to center it against your work. And also on the back side, all these numbers here, we can get it right side up. All of those are your depth of thread, or your double depth of thread for your thread pitch. So you gotta, if you're doing 8 threads per inch, your thread depth is, sorry, I can't read that through the camera, but I think it says 0.162, and that'll give you your actual thread depth. So it's just a much better quality thing. So anyway, let's go over to the grinder. We'll grind this tool bit and grind this tool bit. I'm going to use 3/8 blanks so that they're easy to see. And then we'll test these out. I'll test this in aluminum, and then we'll grind a chip breaker. And I'm very interested to see how this one's going to turn out. I'm down over my grinder. As you can see, it's nothing special. It's just one of the ones that you would pick up at, actually I'm pretty sure I got this at Home Depot. The one thing about grinders that I would recommend though is, if possible, get at least an 8-inch. 8-inch wheels are a little bit easier to find than 6-inch wheels, especially if you want to change. These are the original ones that came with it, the carborundum wheels. I think they're either 40 grit and 80 grit, or 80 grit and 100 grit, something like that. You can change these out for a much better cutting wheel, like a silicon carbide or something like that, rather than the carborundum wheels. These tend to heat up the bits a lot faster than the other ones and produce a little bit less of a smooth finish, but you can take that out with a honing stone. But if you get a 6-inch grinder, those silicon carbide wheels are kind of hard to find in the grit that you want, especially in a 6-inch wheel. So I do recommend these. Also, every one that you're gonna see, or every consumer grade type of grinder, I'm gonna have these little rinky-dink rests on them. As you can see, I modified the one there. The original one is still under here. All I did was bolt a nice piece of steel to the top to give me a nice platform to work with. And especially when you're first starting out grinding tools, take a protractor and just, with some Sharpie, just make your angles that you want. This happens to be 15 degrees from the wheel this way and 15 from off axis this way. So that way there, when I hold the bit, you can see 15 degrees this way, and when you do the top rake, 15 degrees down that way. And this whole table itself is tilted at about, it ends up being about 12 degrees. There are little indents in this, and it can only move at certain points, but that's perfectly fine for me. And the other thing is, when you first before you even turn your grinder on, take something, give your wheel a tap. If your wheel rings, you're fine. If you hear a dull thud, your wheel has a crack in it, get rid of it. The first, also, these things have this little rinky-dink coolant tray thing going on here. Don't even try to use it. It's useless. Get yourself a cup with some water. Much happier. Okay, just in case you can't hear me over the grinder, we're going to first dress this stone, and then we want this corner here to be our cutting edge. So first thing is going to grind 15 degrees off the edge here, like this. Now this table is also tilted up at 12 degrees, so that will take our front clearance too. Grind that. Then we're going to come over to the side. This is set at 12 degrees. We're going to grind our relief on the side there. And then we're going to come back over here and grind our side rake. That's our wheel. Now you don't need to force your bit into there. Let the wheel do its work. There you go, the finished tool. I could put a little bit of radius on the end to do that. Make sure at this angle here is vertical with the wheel. That's all of the radius we need. Now we're going to grind that shear tool, so I need 15 degrees this way, right to the side. Go over to the bench and see what they look like. Alright, here's the turning tool that we just ground. I've already honed it. This with an oil stone. Here's the cutting edge right here. small radius on the front. Let's see if that shows up a little bit better. Tiny radius on the front. The only thing is when you do the radius on the wheel, what I was trying to say over there is you want to make sure that this angle right here, your clearance angle, is touching the entire face of your wheel. So in other words, when you go to do the radius, you don't want to just touch the tip. You want to make sure the whole face of that bit comes in contact with it. It was just a quick little swipe right over, and then you can refine it with the oil stone. Just take it, drag it back and forth a couple of times, and it'll round out nice. Now you can see here is the radius of the grinding wheel right here, and right here is where it was honed on the flat stone. You can see there's a little bit of a dish in it, but that doesn't make a difference. You just want your cutting edge nice and sharp, and here too, and also on the top. So it's 15 degrees on this, 15 degrees from the cutting edge sloped away, side rake. Clearance on the front here, 15 degrees from the cutting edge back. On the front here, 15 degrees from the top of the cutting edge down to the heel, this angle here, and then about 12 degrees from the tip of the cutting edge down to the heel, that way. And that's all your clearance for that bit. Now that shearing tool is this right here. Now this one, you want to make sure that on the inside here, this whole face is your cutting edge. So you want to get rid of that radius of the cutting wheel. So all I did real quick was just take it and touch it against the side of the wheel, just to straighten that out. It's not a good thing to keep doing, but real quick touch, just flatten that out rather than sitting and rubbing it on the stone for a while. This is honed to a nice edge. You can see that's just a little divot right there left over from the radius of the wheel, but the cutting edge itself is honed smooth. The front of this is dead flat glass finish, and this is razor sharp right here. Nice and sharp point, or as sharp as I'm ever going to get it. So let's see how both of these tools work. First, we're going to cut some aluminum with this, and we're going to notice the way the chip curls off of the tool bit, and then we're going to grind ourselves a chip breaker in this and see how much difference that makes. Alright, we just have our regular right hand tool bit in our tool holder. This is just aluminum, so we're going to see how the chips come off of that. You see how they're long and stringy? This is a very light cut. Now if I were to take a deeper one, you see how everything gets all balled up on the end. You get pretty much this giant bird's nest here. And even worse if you take a bigger cut. Now this is aluminum, that's why I'm handling it with my hands. It's not very sharp, so if this was anything else, it would cut my hand to ribbons, so be aware of that. Now we're going to cut a chip break into that tool, so that when this chip comes and curls off, instead of curling and wrapping around that tool bit, it'll break into pieces as it goes. At least that's the plan. Okay, now we're going to put a chip breaker into our bit. And now a chip breaker usually is just a groove parallel to your cutting edge. It kind of goes down at an angle and then sharp point up. So when the chip comes around, it hits this angle, curls upon itself, and breaks. These work great for harder materials, steels and such, but the only problem is with aluminum, aluminum is so stringy and bendy that this still isn't going to break the chip. It'll curl and then want to go down and away from you, but you'll still get long stringy chips. But at least it won't tie up on your bit. Now, what I am going to do, and what I use for aluminum, and keep in mind that this is a left-hand turning tool, is basically kind of little half-moon shape nicked off your cutting edge here. It'll make little C half-moon chips. The only problem is it won't give you as good of a finish, but that's okay because you can hog it down with this and just put in a finishing bit and do your last pass or so and get a nice finish out of it. So this works pretty good. Now the way I cut them, especially the groove, is with a Dremel tool, which everybody should have. This is like, use these for everything. With one of these cutoff discs, the bigger ones that have that little quick lock fitting, not so quick lock, that all you would do is just take your bit, and this is just a blank, and run a groove down it, and it works out pretty good. I've already done it to my bit, where did I put it? I had it in my hand 2 seconds ago. It ran away. Oh, there it is. You can see I put a little nick in the blade in the front. Right there. Not that deep. And still at a flat angle to the bottom there. Or as flat as I could get it. And I honed the tip. So that should give us a nice broken chip when we use it. Now also, I told you I was going to show you how to cut your high-speed steel for your boring bars. I do that the same way. You can see I started grooving that around. I use one of these, and it cuts really easy and really nice. Now you remember how it cut last time? You can see these are the chips that are coming off of it now. Now they're nice and broken. Not long and stringy. Oops, sorry. They're not long and stringy. And they're not a ball. And it's an okay finish. I mean, you can get much better with a nice round tool bit. Ignore that, all nasties, but it's not too bad. Alright, so now I'm gonna flip this around so we have a surface that looks like this, and we're gonna try that shear tool and see how that works on aluminum. Alright, I got you an overhead view because I want you guys to get as good of a view of this as possible. We're touching about in the middle of that tool, so only take a couple of thousandths here. See what happens. a really nice finish, actually. It's a lot better than the other one. You can see, if you notice, the chips that came off of it. Let's see if I can grab one. I don't even know if you can see that. Really, really thin. Try moving this down a little bit. Contact more in the middle of the tool. Speed up our lathe. It's a damn good finish, actually. I don't know how well the camera will pick up the difference in the finish, but you can see, or I can actually feel the difference. And you can see the swarf is like really, really fine. Looks like that kind of reminds me of a just a thinner version of that the stuff you put in Easter baskets, that grass. Let's put a piece of 12L in there and see how it likes that. Okay, here we go with some 12L14. Yeah, a little bit of run out. It's not a full cut, so. I don't even know if you can see that swarf that came off of there. Never seen anything like that before. It's a decent finish. It's got some surface tearing, but usually 12L likes a deeper finish cut. Usually if you go too shallow, it kind of tends to tear and ruin the surface. So I got a little bit of surface tearing, but it's not a bad finish. I could probably achieve a little bit better with taking with a regular tool and a deeper cut, just by what I'm looking at here. But I got some 1018. We'll try that. I'm assuming that's going to be a little bit better. Actually, you know what? Before I try that, let me try this with some. Take another couple of thousandths. I'm going to try it with some cutting fluid. That's a good surface finish. I like that. It works better with the cutting fluid. I'm going to compare all these afterwards too, side by side. So, alright, let me get a piece of 1018. Put that in there. Alright, got a piece of 1018 in there. that's a really good finish. That looks like it was almost finished with the file, with the smooth file. Let's try a couple more. Some cutting oil. I like that. That's the best finish so far. You can see, I don't even know if you can see, that's the swarf. Looks like steel wool. There's a bunch of it right here. Alright, now I'm going to throw a curveball at it. What we have here is the gummiest metal known to man. This is from either Lowe's or Home Depot. It's whatever they call their welding steel or weldable steel. I have no idea what it is. It is the gummiest thing under the sun. I just use it for fixtures if I need to. This is actually what I use to mount the pulley on from my bandsaw when I chewed it up on the lathe. So I want to see if it can actually get a good finish on this. If it can, I will be extremely, extremely impressed. Well, I'm pretty damn impressed. It's a little rough to the hand, but I'll show you the difference between this finish and the one that I use with a regular tool. Let me try a little bit of oil on that, see if that cleans it up any. Wow. That now that's something. Alright, let's try a little bit of brass. 360 free machining brass. Now this is a notoriously grabby material. It's cutting no problem. It's not getting sucked in, and it's still making those wispy cuts the swarf there. All right. Let me dig in my stash and see if I have some stainless. I'm not sure if I do. This was in my pile of mystery metal, and it's non-magnetic, so I'm assuming it's some grade of stainless steel. So we'll see if this destroys the bit or not. Actually, I want to turn that a little slower since it's going to be hard as hell. Wow. That actually cut it. Well, call me surprised by this one. Here's the swarf that's coming off of this. You can see it's kind of steel woolly. Almost like hair. Like a giant fur ball of metal. Tool life, the edge of the tools held up pretty well, even with that stainless. And you can see just a slight little hickey in the very, very middle. That's probably from that last bout with the stainless, but otherwise, I mean, no chips, no degradation to that tool edge, really. Still pretty sharp. Now here's our aluminum test. This was cut with the regular bit. This is what we just cut. Get the fingerprints off of there. This this looks pretty good, but up close, I mean, you can see the tooling marks in it. Especially right here. This is a lot smoother. It looks almost ground. Our brass. Now I didn't use any kind of fluid on this. Just give a pretty nice finish. .1018, very nice finish on the 1018. That looks almost like a ground finish. It's very, very nice. I like that a lot. 12L14, I went over it with some cutting fluid afterwards. It gave a better finish. Pretty good on the 12L. Not too bad. I think you can get pretty much the same finish, or maybe a little bit better just with a regular tool bit taking a deeper cut. But I mean, no complaints on that finish either. And then the two things that surprised me the most is, one, it cut unknown stainless steel here, and it actually gave a pretty decent finish. And the cutting edge held up. You got a little bit of tearing in there. It's not too bad. And probably the biggest surprise is this here. This part right here I had turned to fit the pulley from the Harbor Freight bandsaw I have, and that's the finish I got with my regular tools. Now look at the finish I just got with that. That's impressive, or at least that impressed me, because this stuff is beyond gummy, and it just tore and just made a horrible finish with a regular tool. But that thing, I sliced right through it and gave a pretty damn good finish. I mean, that's nice and smooth. That's how that works. So that's the basics of, my tool bit grinding, and you saw me grind the regular right hand tool bit, and we saw uses of this little guy here, and that should be pretty much it for now. We'll come up with another video soon, and we'll see you on that one.